Let's look at our last Gradle file before continuing our own build.gradle. Hello everyone, this is Andy Reza. Welcome to the Mentor Code Lab. In previous video, we talked about the package info Gradle file and task. And we found that we annotate our package info as internal when we are working with IMPL or mixin. Now, in this video, we are doing something on top of that. First of all, we are registering a task called validate annotation inside Fabric. Again, we don't care about the output we pass through. We are doing it on these source files. The source client Java, source main Java, and if we have a test mod on test mod Java and test mod client.java. Now, I don't have any test mods. Bye-bye to that. Then we say the checking depends on this validation. So just like before, anytime we want to run the check, we will run through this task. And remember, the check task is being called each time we want to build or publish to Maven actually. Now here we are defining two regex patterns for our annotations. Remember, we had this API status dot internal, and this is a escape character. And then the next one is @ environment. Then we define our folders. So we look into the API, IMPL, mixin, and as I said, we don't have any test folder. And now we want to go through each folder and check if we have the annotation for the environment. Environment annotation is being used for very special coding. For example, on server client coding, we annotate them as environment, things like that. Normally, you shouldn't have it inside your library. For whatever reason, Fabric API have a very strict policy on using that @ environment, and they say it's never allowed. So if you have @ environment, it will throw an exception. Now remember, when you throw an exception, they will break the process. It's not falling back here. It's an exception. It says that, hey, you have an environment annotation somewhere in this file, and then break the process of building. Other than this, the other annotation is this API status.internal. Now this is interesting. We say that if the folder is API, then pass it. We don't care. This is working hand in hand with the previous script that was working inside IMPL and mixin. In other words, we are just checking the IMPL and mixin. Now, if we find that API status internal, then we throw an exception again. What? Didn't we add it on top of some file there? Yes. The thing is that package info is not being checked here. In other words, we are checking that we only and only and only have that API status internal in the API packages. Oh, it's auto-generate for IMPL and mix. In other words, if we annotate any handmade Java class inside mixins or IMPLs as status internal, here we get another error that says, hey, why did you put that annotation? It shouldn't be there. Only the package info file that I generate for you is allowed to have this annotation. So this is working hand in hand with this one. However, again, we are looking on a very wrong folder structure. We need to fix that folder structure from ourselves, and that is dev/dementor. So this whole thing will be dev/dementor, and that is our validate annotations. Now, it's interesting to have these. Each one of them is doing something critical. As we said, some of them is validating the modules themselves. Some is using to bump the versioning when we are working on a hierarchy of libraries. One is checking the package infos, and finally, the other one is checking that we are annotating our libraries correctly. One is changing the focus and deleting the focus file and making the core as a dependency for everyone. And finally, the build source is actually being used as the scripts that we will call inside our build source like here. Something that I need to mention, none of these scripts are being used or registered or called right now. So even though that few episodes back, I copy pasted them and resynced the Gradle, you don't see any Fabric group under verification. You don't see anything from these, and it won't happen. It basically won't happen because our build.gradle is not containing anything related to any one of these scripts yet. And from now on, actually, we want to add those behaviors into our library as we go forward. Okay. We have time, so I will continue on build.gradle. Up until now, we just imported a bunch of our libraries and classes and defined meta projects and some debug arguments and a variable for our versioning. Now, we will define a task, not a real task, but a method here that we can call ourselves, and that is get subproject version. So we say def means define, get subproject version. Here we say we want a project and we call it project. Basically, we are saying that, hey, I'm sending a project for you, define its version for me. And as always, I will start copy pasting because honestly, it's just time consuming to type these comments and other things. So they get the version from the gradle.properties file. Okay, to get the version, it's really easy. We say that the version equals project.properties $project.name-version. Now remember, normally outside of this method, whenever you have the project somewhere in the name, for example here or here, it means the top level project, okay? But here it means this variable. And if you look, this one was white, this is orange. So here we are not referring to the top level project, but the project that we sent in. If you want to, you can change this name later to avoid confusion. The next thing we want to check if we got this version under the properties or not, under the gradle.properties or not. For example, we may mistyped glibs-core, or we may not have dash version, we may have underline version. So for example, if any one of these happened, then just throw a null point exception, say that, hey, we didn't find this version anywhere. After that, we say that from the project, get the provider, from there, read the environment variable CI. If it's present, then that's the version for us. If not, add a plus local. Now remember, instead of this, we have is CI. But is CI, is it acceptable from here? Because we defined it on top. And it says no candidates found for method call is CI. If not is CI anyway, then return. However, if we want to, we can get it from there and put it there. Okay, so now we defined is CI again. Anyway, if you have the CI, that's okay. If you don't, then add the plus local to the version name. And then we say has provider. The has provider equals to project providers of commit hash value source. Now, remember, it's one of our build sources, commit hash value source. And it says that it returns this argument called on git. Anyway, it's getting a hash source, I think. And then we says parameters.directory equals to project.name. So basically, we are setting the parameters for the directory based on our name here. And finally, we get this. Return version plus hash provider get substring, and we will talk about this in a few seconds. Then we want a SHA-256 hexadecimal codec, and from there we get the first 2 digits. Now, what is this substring 8? It means that get the first 8 values from there. And let's say that we want to log it. So we say logger.lifecycle. I want the version column. Let's define this first. So def temp equals to this. And then before returning the temp, we plus the temp, and then we return the temp. Okay, and what's wrong here? It should be able to. Okay, if you can't, I just take this from here to here. Whatever. And then let's call it, I don't know, let's call it on something. Let's call this guy on a project. Well, let's see what will happen. I don't know, because honestly, this line is just asking for the version and then adds things to the end of that version as metadata. So I think that's okay. I will remove this part because I did like to see the result, but now that I think about it, the original version is the version that we are getting from the gradle.properties, for example, this. And let's say that we are in CI, so that would be it. So we are not adding any branches or anything else. Then we just create a hash code, gets the 8 first digits of the hash code, and then 2 digits from a SHA-256, add them at the end of that version, make that version unique. Oh well, we will see the result later. But long story short, if we ever call this get sub project version, means that we will provide a very unique version number based on the hash code and the encryption of actually Minecraft version. So basically, we are dedicating our version both for the subversioning and the Minecraft versioning system. Okay, now after this one, we will have a bigger one, and that is module dependencies. Let's talk about that in the next video. Have fun, everyone. Bye.